If you have been paying close attention lately in the blockchain space, you probably have come across the term zero-knowledge proof. So what the hell is that? And why is it so important? Especially in blockchain, we are consolidating transactions and making them more gas efficient. But let me go back and explain to you why zero-knowledge proof is a big deal. Imagine that you need to log into a website. Let's put this scenario right here. You're probably going to be using a username and password. You're going to be exchanging that information, which is sensitive information, with zero-knowledge proof. I don't need to share the knowledge. I don't need to share the details that will authenticate, or in this case, will verify that I am who I say I am. In the case of zero-knowledge proof, what I'm going to be doing instead is I am going to tell the verifier the information that will guarantee, or it will confirm that I am who I say I am without actually saying the information. So basically, zero-knowledge proof, it's summarized in the following. Please tell me that you say who you say you are without actually telling me who you are. And it's like, okay, well, I don't understand. Let's picture the scenario. So I am going to be the prover, and I will have someone that is going to be the verifier. If I want to process a transaction on the blockchain, I will be sending my transaction into a validator. The validator is going to grab the transaction, it's going to do the whole hashing, it's going to process that Merkle tree, it's going to go over the hashes to confirm that the transaction is legitimate, that there's no manipulation in the transfer of that data to request that transaction to be processed. So in the case of zero-knowledge proof, I am going to slightly eliminate that step by pre-authorizing or pre-proving or telling the verifier that I say who I say I am. So in this scenario, I am going to say the following. The verifier is going to ask me, hey, do I know you? Who you are? Do you know me? Okay, how can I trust you? And the prover is just going to say, well, for a fact, I know your phone number. Let's imagine the scenario. I know your phone number. The verifier is going to say, well, if you do know my phone number, that means that you know me and probably you are trusted. But don't tell me your phone number. Prove it. What I'm going to do, I am going to call you. I'm not going to tell you the phone number. I'm just going to call you to confirm that I say who I say I am, right? I proceed to call. The verifier receives the phone call and it says, I am definitely talking to the real person. So I am going to use that authentication mechanism to tell the blockchain, hey, by the way, I already have a pre-approval, or I already went through the verification challenge. That's one of the key items in the zero-knowledge proof. So instead of me, the prover, having to provide password, username to log in, I am going to be answering a challenge. The challenge is going to be provided by the verifier. The verifier is going to ask me something, and if I say who I say I am, I should be able to answer that, or I should be able to resolve that challenge. That is what is called a verification challenge. Okay? So, with that said, I am going to proceed to perform the verification. I will do the challenge, and if everything goes well and I do the verification successfully, I will be allowed, or I will be approved, right? So that's how we pre-approve that transaction. Here's where it starts getting interesting. I'm going to say there's many ways, or there's several ways to do the zero-knowledge proof verification. The two main ones, and you're going to be hearing a lot about them, is going to be the ZkSNARK and the ZkSTARK. ZkSNARK, it stands for, bear with me, succinct, non-interactive argument of knowledge. Succinct, small. Non-interactive means that I already went through that pre-approval, okay? I went through that pre-approval and I already built some sort of trust between the platform, in this case the verifier, and myself. So there must be already a center or a system of trust pre-established between me and the verifier. And we have another mechanism that is called ZkSTARK, Scalable Transparent Argument of Knowledge, okay? So in this case, I will be building that trust every time that I need to send a transaction, okay? So I need to build that trust and execute the transaction, which means that yes, it's going to take a little bit more time, but not necessarily to the point that it's going to affect the transaction processing time. It's going to take a little bit more space because I have to build the entire set of verification steps, or in this case, the verification challenge. And I have to send that in the protocol between the prover and the verifier, so then everything gets executed. So it's slightly bigger in size to process, but still, is definitely more scalable. And the reason why it's more scalable, because I don't need to do a trust ceremony, and that is on the ZkSNARK side of things. We mentioned in ZkSNARK, we have already a trust built. We already pre-built that trust. So in ZkSTARK, we have to build the trust every time that we perform those calls, okay? ZkSNARK has the trust ceremony, and that is the process in which I will be building that trust, that initial trust that I can use to continue doing transactions. But there must be an initial trust that has to be built. That requires an infrastructure to be set, and we have to store all those details and all that, which limits the scalability of a platform, or in this case, of the blockchain. If we do it without having to have a pre-trust relationship, I'm going to call it, but it's the trust ceremony, then I can authenticate pretty much everyone, right? It's just that I need to do the verification as I'm processing that request. To summarize, and I am going to close this high-level, very quick introduction into the ZkProof, ZkSNARK, ZkSTARK, and ZkRollup. What is ZkRollup? It is basically a mechanism, and this is where we are going to start seeing blockchains adopting the ZkRollup, because it allows me to grab a batch of transactions, combine them all into one big package, and send that as a single transaction. Why? Why am I able to do that? I am able to do that because I already pre-approved that transaction. I already went through that initial trust. I built that trust between the prover, which is going to be the one who is executing the transaction into that blockchain, and the verifier. So I already went through the hassle of making sure that the transaction is legitimate, right? I am going to be doing is, instead of me processing transactions one by one, every time that we have a transfer on the blockchain, every action on the blockchain, every call to a smart contract, well, that is a transaction, right? I am going to grab all those transactions and I'm going to combine them onto one package. I'm just going to store every single transaction in that package, and I will process that as a single transaction, which means what? Less gas fee, because it's only one transaction instead of having every single transaction incur or process involves, spending gas fees, which is amazing. So that is the ZkRollup. And as we move here into this channel, I am going to be working with that. There's a lot of material that I'm going to be covering, but that is one material that we definitely want to cover, because who doesn't want to have a blockchain that is free from transaction fees? Everyone, right? And we want speed, because speed equals money. And money equals progress. We're definitely going to be building that. Alrighty, so that was for this short video. I hope that you enjoyed my quick introduction and you learned a lot. And if you did, please do me a small favor. Hit the thumbs up, subscribe if you haven't subscribed to. Hey, and we'll see you on the next video. Bye.